Hello dear students, this is the introduction session which will cover about AI definitions. Today we will try to understand this part. So let us try to understand the objectives and outcomes of this particular session. The objective is understand different definitions of AI, get exposed to Turing test, different aspects of artificial intelligence based on mimicking human and being rational. This you need to understand. And outcomes what we expect is remember the definitions of AI, understand how Turing test is conducted, and the required capabilities of a program to pass the Turing test. We expect you to comprehend the categorical approach of AI in mimicking human and being rational. So let us go ahead. Introduction to AI. What basically is an artificial intelligence? Now, this has become a buzzword. Everybody says artificial intelligence. Basically, artificial intelligence is a branch of computer science which is concerned with making computers behave like human beings. So, behave in the sense both thinking as well as acting. As far as definition is concerned, very specific definition is not there, universal definition, but we can see like major AI textbooks define artificial intelligence as the study and design of intelligent agents, the agents which are intelligent. We will see what is an agent in the next session, where an intelligent agent is a system that perceives its environment and takes actions which maximizes its chances of success. So whatever actions it does, it should maximize the chance of success. It should pursue, it should take the input and then act accordingly. So it's like a human being. Whatever we try to do, we try to maximize our success. Now, as per John McCarthy, he is the one who has coined the term artificial intelligence. So John McCarthy, who coined the term in 1956, defines it as the science and engineering of making intelligent machines, especially intelligent computer programs. So let us try to understand the different AI definitions which have been categorized into 4 approaches. The table below shows that. So this is a table. We have got 4 parts here. We can understand. One is systems that think like humans, systems that think rationally, systems that act like humans, systems that act rationally. So all the definitions of AI have been categorized into these 4 categories. Now let us try to understand the first definition given by Haugland in 1985. The exciting new effort to make computers think, missions with minds in the full and literal sense. So around 1985, Haugland insists on computers thinking where missions with minds in the full and literal sense. Now, when it comes for acting, the art of creating machines that perform functions that require intelligence when performed by the people. So this is what as per Kurzweil in 1990. So artificial intelligence is all about creating machines that perform functions. So it is like action, acting, and the function should be as such. When performed by people, it requires some intelligence. Such a action, such a function, the machine is creating. So it is like mimicking the action of humans. Hence it is under act like human. Now when it comes for the other part, we have Charnock and McDermott during 1985, they have given a definition: the study of mental faculties through the use of computer models. So now here it is mental faculties, how a person thinks and what is right. The rationality is about doing the right thing. In the same way, acting, under acting rationally, we have Pule et al. In 1998 have given a definition. Computational intelligence is the study of the design of intelligent agents. So these are the 4 definitions. If you observe carefully these 4 definitions, the upper two parts, horizontal ones, they emphasize on thinking, shown in red letters. Systems that think like humans, systems that think rationality. So the horizontal one is speaking about thinking. Those two definitions are insisting on thinking. One is like humans, the other one is not just like human but thinking rationally, because sometimes human beings also behave irrationally. Now if the system behaves irrationally, it's a Herculean task to control it. So we need to take care that systems think rationally, not just thinking but think rationally. When you look at the second part, the lower part, that is again shown in the red color for the proper emphasis. So systems that act like humans, systems that act rationally. These two definitions in the lower part gives you insisting on the acting like human beings and acting like rationally. So that is like behavior part. The first one was thinking part, the other one was behavior part. Now when we look at the vertical column, so the second column I am insisting on first. So these column definitions, they speak about rationality. It's not just a system, but the system should be rational in its behavior, irrational in its thinking. Whatever it does, it should be a right thing, not just doing. We cannot, deploy a robot to kill people. So it is irrational. In the same way, when you look at the left-hand part, the vertical column, what we are looking at, systems that think like humans, systems that act like humans. So these two definitions emphasize on the thinking, being like human. The earlier ones were being rationally, and the first part is, this part is like humans. So these are the definitions of artificial intelligence. Now let us try to elaborate on these things. Acting humanly. In case of acting humanly, around 1950, Alan Turing has proposed one test by name Turing test, the Turing test approach. In his seminal paper, he has proposed this. Alan Turing has proposed Turing test. The point is, like, the computer is asked questions by a human interrogator. It is something like a human sits in one room, and the other side of the wall there may be a person and a computer. Now the human doesn't know with whom he is actually interacting, but he has to identify whether the answer is being given by the human being on the other side or on the computer. If the computer can misguide the human being as a human being answering, then the computer wins. So the computer passes the test if a human interrogator, after posing some written questions, cannot tell whether the written responses come from a person or not. So that confusion is created and the human being fails to identify who is responding. Then the computer is considered as winning. So this is how the Turing test can be depicted. You can see one person sitting over there asking the question, what is 2 plus 2? And the other side, there is another person as well as a system on the other part of the room. So one is answering 3 and the other one is answering 5. But now whoever is answering, the person should be able to, the interrogator should be able to identify whether it is a human or a computer which is answering. So this is not easy to program such a program to do it. So programming a computer to pass, the computer needs to possess certain capabilities. What are those capabilities? Because it has to answer the written queries, so it should have natural language processing that enables it to communicate successfully in English. And whatever it knows, whatever it hears, it should maintain the information so that after a certain time period, if somebody else asks based on that information, it should be able to answer. So it needs knowledge representation to store what it knows or hears. And then it has to apply some reasoning on the stored information to answer the questions or to draw the new conclusions. So it requires some part of automated reasoning. Automated reasoning to use the stored information to answer questions and to draw new conclusions, as well as to adapt to the new circumstances and to detect and explore patterns of queries and answers being come across. It need to have machine learning. And To pass the complete Turing test, the computer will need not only these things, but it may also need the vision, computer vision, because sometimes I may be passing an object and it should be able to identify the object and give me some answer. So to pursue the objects, as well as some robotics, maybe to manipulate the objects and move about. When I give, it has to take, or when it give, it should be able to return me back something. So that's like robotics is required. Now, thinking humanly, the cognitive modeling approach considered as, we need to get inside actual working of human mind. If I want to know how, so if I want to mimic a system to think like human, then I should know how a human being thinks. So we need to get inside actual working of the human mind. How it can be done? It can be done through introspection or through psychological experiments. I can understand how a human being is thinking. So in case of introspection, trying to capture our own thoughts as they go by. We introspect what is that we are thinking, how we are thinking, what about we are thinking. And through psychological experiments, sometimes the psychologists try to understand the patient's ideology. Alan Neville and Herbert Simon, who have developed this GPS, General Problem Solver, tried to trace the reasoning steps to traces of human subjects solving the same problem. So they tried to understand how a human being is solving a problem, maybe using decomposition, maybe using some logical things. So in the same way, they tried to develop this general problem solver. Now, the interdisciplinary field of cognitive science brings together computer models from AI and experimental techniques from psychology. Cognitive science is a bit a larger one, where it has got models from artificial intelligence as well as psychology based experiments, which try to construct precise and testable theories of the workings of the human mind, based on which we can further develop the agents. So when it comes to thinking rationally, that is understanding the laws of thought approach, the famous Greek philosopher Aristotle, he was the one of the first to attempt to codify right thinking. He tried to code the right thinking. How? He has come out with something called as syllogism, that is irrefutable reasoning process of right thinking is proved using his syllogism. His syllogism provided patterns for argument structures that always yielded correct conclusions when correct premises are given. So, for example, like you say, so for example, like Socrates is a man, all men are mortal. Now, when we have these two sentences, Socrates is a man and all men are mortal, so obviously we can say Socrates is mortal. That is what happens in the deduction of answer. Therefore, Socrates is mortal. So these laws of thought were supposed to be governed in the operation of the mind. Their study initiated a field called logic. Now, acting rationally. We all know we have already discussed this rational agent at the beginning. An agent is something that acts. Computer agents are not mere programs, but they are expected to have the certain attributes. They should be operating under autonomous control, perceiving their environment, persisting over a prolonged time period, adapting to change. Now, these four capabilities are very important. If they have these four capabilities, then autonomous is like taking their own decisions. And now we will be having a rational agent that acts so as to achieve the best outcome. Thank you. Happy learning.